2-butoxyethanol is an organic compound with the chemical formula BuOC2H4OH. This colorless liquid has a sweet, ether-like odor, as it derives from the family of glycol ethers, and is a butyl ether of ethylene glycol. As a relatively non-volatile, inexpensive solvent of low toxicity, it is used in many domestic and industrial products because of its properties as a surfactant. Production: 2-butoxyethanol is commonly obtained through two processes. The ethoxylation reaction of butanol and ethylene oxide in the presence of the catalyst, C2H4O plus C4H9OH or C4H9O C2H4OH, or the esterification of butanol with 2-chloroethanol. In 2006, the European production of butyl glycol ethers amounted to 181 kilotons, of which approximately 50% was 2-butoxyethanol. World production is estimated to be 200 to 500 carats per hour, of which 75% is for paints and coatings and 18% for metal cleaners and household cleaners. In the US, it is considered a high production volume chemical because greater than 100 million pounds of this chemical is produced per year. Uses: 2-butoxyethanol is a glycol ether with modest surfactant properties. In use since the 1930s, glycol ethers are solvents that dissolve both water-soluble and hydrophobic substances. Glycol ethers consist of two components, an alcohol and ether. According to the nature of alcohol, molecules of this class can be divided into two groups, E-series and P-series, which correspond to ethylene and propylene respectively. Glycol ethers are selected for specific purposes, such as solubility, inflammability, and volatility. Commercial uses: 2-butoxyethanol is a solvent for paints and surface coatings, as well as cleaning products and inks. Products that contain 2-butoxyethanol include acrylic resin formulations, asphalt release agents, firefighting foam, leather protectors, oil spill dispersants, degreaser applications, photographic strip solutions, whiteboard cleaners, liquid soaps, cosmetics, dry cleaning solutions, lacquers, varnishes, herbicides, latex paints, enamels, printing paste, and varnish removers, and silicone caulk. Products containing this compound are commonly found at construction sites, automobile repair shops, print shops, and facilities that produce sterilizing and cleaning products. It is the main ingredient of many home, commercial and industrial cleaning solutions. Since the molecule has both non-polar and polar ends, butoxyethanol is useful for removing both polar and non-polar substances, like grease and oils. It is also approved by the US FDA to be used as direct and indirect food additives, which include antimicrobial agents, defoamers, stabilizers, and adhesives. In the petroleum industry: in the petroleum industry, 2-butoxyethanol is a component of fracturing fluids, drilling stabilizers, and oil slick dispersants for both water-based and oil-based hydraulic fracturing. When liquid is pumped into the well, the fracturing fluids are pumped under extreme pressure, so 2-butoxyethanol is used to stabilize them by lowering the surface tension. The compound is also used to facilitate the release of the gas by preventing congealing. It is also used as a crude oil water coupling solvent for more general oil well workovers. Because of his surfactant properties, it is a major constituent in the oil spill dispersant Corexit 9527, which was widely used in the aftermath of the 2010 Deepwater Horizon oil spill. Safety: 2-butoxyethanol has a low acute toxicity, with LD50 of 2.5 grams per kilogram in rats. Laboratory tests by the U.S. National Toxicology Program have shown that only sustained exposure to high concentrations of 2-butoxyethanol can cause adrenal tumors in animals. American Conference of Governmental Industrial Hygienists reports that 2-butoxyethanol is carcinogenic in rodents. These rodent tests may not directly translate to carcinogenicity in humans, as the observed mechanism of cancer involves the rodent's forestomach, which humans lack. OSHA does not regulate 2-butoxyethanol as a carcinogen. Disposal and degradation: 2-butoxyethanol can be disposed of by incineration. It was shown that disposal occurs faster in the presence of semiconductor particles. 2-butoxyethanol usually decomposes in the presence of air within a few days by reacting with oxygen radicals. It has not been identified as a major environmental contaminant, nor is it known to bioaccumulate. 2-butoxyethanol biodegrades in soils and water, with a half-life of 1–4 weeks in aquatic environments. Human exposure 2-butoxyethanol most commonly enters the human body system through dermal absorption, inhalation, or oral consumption of the chemical. The ACGIH threshold limit value for worker exposure is 20 ppm, which is well above the odor detection threshold of 0.4 ppm. Blood or urine concentrations of 2-butoxyethanol or the metabolite 2-butoxyacetic acid may be measured using chromatographic techniques. A biological exposure index of 200 mg 2-butoxyacetic acid per g creatinine has been established in an end-of-shift urine specimen for U.S. employees. 2-butoxyethanol and its metabolites fall to undetectable levels in urine after about 30 hours in human males. Animal studies harmful effects have been observed in non-human mammals exposed to high levels of 2-butoxyethanol. Developmental effects were seen in a study that exposed pregnant Fisher 344 rats, a type of laboratory rat, and New Zealand white rabbits to varying doses of 2-butoxyethanol. At 100 ppm and 200 ppm exposure, statistically significant increases were observed in the number of litters with skeletal defects. Additionally, 2-butoxyethanol was associated with a significant decrease in maternal body weight, uterine weight, and number of total implants. 2-butoxyethanol is metabolized in mammals by the enzyme alcohol dehydrogenase. Neurological effects have also been observed in animals exposed to 2-butoxyethanol. Fisher 344 rats exposed to 2-butoxyethanol at concentrations of 523 ppm and 867 ppm experienced decreased coordination. Male rabbits showed a loss of coordination and equilibrium after exposure to 400 ppm of 2-butoxyethanol for 2 days. When exposed to 2-butoxyethanol in drinking water, both F344 per Newton rats and B63F1 mice showed negative effects. The range of exposure for the two species was between 70 mg per kilogram body weight per day to 1300 mg per kilogram body weight per day. Decreased body weight and water consumption was seen for both species. Rats had reduced red blood cell counts and thymus weights, as well as lesions in the liver, spleen, and bone marrow. Regulation in Canada Environment and Health Canada recommended that 2-butoxyethanol be added to Schedule 1 of the Canadian Environmental Protection Act, 1999. Under these regulations, products containing 2-butoxyethanol are to be diluted below a certain concentration. Only those in which the user performs the required dilution are required to include it on labeling information. Regulation in the U.S. 2-butoxyethanol is listed in the U.S. state of California as a hazardous substance, and U.S. employers are required to inform employees when they are working with it. It is approved by the Food and Drug Administration as an indirect and direct food additive for use as an antimicrobial agent, defoamer, stabilizer and component of adhesives. After it was deleted from a UN list of substances requiring special toxicity labeling in 1994, and a subsequent petition by the American Chemistry Council, 2-butoxyethanol was removed from the U.S. Environmental Protection Agency's list of hazardous air pollutants in 2004. The safety of products containing 2-butoxyethanol is normally used as defended by the industry trade groups the American Chemistry Council and the Soap and Detergent Association. References. External links: International Chemical Safety Card 0059, NIOSH Pocket Guide to Chemical Hazards, Incham SIDS Dossier, Eastman EB Solvent Info, TOXFAQSA sent for 2-butoxyethanol and 2-butoxyethanol acetate from the Centers for Disease Control.